Hello. I hope everyone's having a good evening or good morning if that's what it is for you. Welcome to Neurofeedback and Chill weekly live stream where we talk about neurofeedback and other forms of biohacking. And tonight we're going to talk about aging. 10 brand new biohacks. There's all kinds of things hitting the research these days that seem like they're interesting in the biohacking landscape with regards to aging. So I thought I would do a little bit of a review of some recent stuff. Hey, folks, I see Stunks left a question. Stunks, if you're here, I'll take a minute and answer your question. But if not, it's the kind of thing that might deserve its own live stream or its own canned video. So let me know if you're around. And hey, Radar Ashwood, nice to see you again tonight. Hope you guys are well. So we're going to talk about aging a little bit. If you haven't seen one of the Neurofeedback and Chill live streams, I will generally set myself up with some neurofeedback, chat about it, answer any questions about neurofeedback as we go, and then typically get into some other biohacking topic. And tonight I wanted to get into some of these brand new research findings, all of which sort of say things about how we can see features of aging differently, or maybe have different interventions that have some impact. And a couple of these, I think, deserve their own, 10 or 15 minute specific produced video. So as we go through them, please let me know, or if you're watching this later, let me know which of these topics, which of these short little blurbs that I'll go over is something you want me to expand in some depth. Because I have ideas about all these things, but I haven't gone deeply into all of them. Wanted to kind of do a little bit of a survey. So let me bring up my neurofeedback session. And tonight, let's see. So aging, I think, let me turn off the timer. I think tonight for a session, I'm going to do a C4 minus A2 for executive function and sleep mixed with a PZ minus A1, which will have some impacts on the posterior cingulate, impacting both speed of processing and stress response, which I think fits the topics tonight because two of the findings seem to overlap there a little bit. So I'll get into that for you guys in a second, but let me first set my session up. We're going to do a, let me see, select myself. There I am. So let's see, plan this. So this is eager, and let me see, is my head covering it? Yeah, kind of. Let's move it over a little bit. Ignore the fact that I'm looking away from it so I can show you what I'm doing. All right, so right now it's set up to C3. Let's clear that. This is the software called Eager. We'll do C4 minus A2, I think that's fine. And we'll do a 4 to 7 inhibit, meaning we're gonna train down my theta waves. We'll do an 11.75 to 14.75. So I'm rewarding a low frequency beta called SMR, or sensory motor rhythm. And SMR beta is used for staying asleep, for falling asleep, for sitting still, for resisting impulsivity. It's used by animals like cats to hold perfectly still while they're noticing prey so they can pounce from a place of focus and deep relaxation. Good SMR ability is literally the opposite of ADHD, this physical fidgetiness and lack of ability to stabilize the attention. You'll also find that a lot of times in ADHD, there's a sleep issue. You can look at the work of Martin Arns, A-R-N-S, out of Netherlands, out of the brain clinics in Utrecht, showing that at least some modeling, some overlap of ADHD might be considered a little bit of a sleep regulation issue in the fact that it has issues with SMR, sensory motor rhythm, and you also get sleep spindle, which is the same thing as SMR, just when asleep. You get sleep spindle alterations and sleep architecture changes often in the ADHD person. So, all right, C4A2 SMR, and let's run that for 12 minutes. I have a lot to talk about. And then we'll do a PZ minus A1, eyes open, because it's hard to read and look at questions, eyes closed. So let me clear this. Clear, there we go. PZ minus A1, perfect. 4 to 7 inhibit again, but now we're going to reward alpha. And we're going to do an alpha from 7 to 10 hertz, which is alpha 1, or the idling alpha. And a good, robust, healthy alpha in this range will let me turn off rumination, threat sensitivity, over-evaluation, that kind of stuff. And if I'm tired, this frequency will also speed up my speed of processing a little bit. 20 to 32 back there. Okay. And we'll run this for another 12 minutes. That seems fine. All right. So let me go back and look at the live stream while I'm setting up some wires, and I'll answer some questions for you guys. Hey, T. How are you, sir? Nice to see you. Just set myself up with some eager, and let me, dropping my paste. Bear with me for 1 second. I managed to spill some water near a computer, which is not the most exciting thing in the world. So just going to get something. There we go. Okay. So too many things next to my desk. Knocked a bucket of 1020 paste over, and it knocked over a bottle of water. So if I suddenly go offline because the computer shorts out, you'll know why. Excitement, danger. Who knew this was a primetime show? All right, so I'm going to set myself up. I took my headset off because I am going to put some wires on. So let me know if the audio goes wonky because the headset is not on, so I can't hear it. And so I'm going to do some C4 minus A2 with my eager here. So let's see. Let me grab some electrodes. Eager uses a pretty basic setup. It works really, really well. A lot of traditional neurofeedback works just as well as the complex stuff, but it's a lot easier to control. So you have a lot more ability to carefully steer the process when doing 1 and 2 channels at a time, individual locations at a time, etc. All right, I got some little paste bucket. I'm going to paste up my electrodes. So I'm curious, of those of you who are watching, there's already 5 or 10 of you. How many of you have done neurofeedback in the past day or two? And, or maybe a better question, if you haven't, what's your favorite neurofeedback or your favorite biofeedback if you've done any of those things? All right, so left ear, got a clip on it. Pretty easy to find your ears. That's the blue wire. And tonight I have plugged in a little UWiz, a 4-channel amplifier. And on this amplifier, the red minus black sockets create the first channel, and the green socket in the middle is the ground. So let me put this left ear into the black socket, into the ground socket in this case. And then my right ear, I'm doing C4 minus A2. Hey, Radar is asking, is referencing to an earlobe roughly the equivalent of referencing to the mastoid? If I want to train CZSMR, would referencing to the left mastoid bone be basically the same as doing A1? It's similar. You got to be a lot more careful with this substituting an M1, a mastoid 1, in for A1 in a QEEG. You really can't substitute. Now, if every single QEEG you do with a cap is always mastoids, then you can get away with it because you'll always see the same thing. But it's not good practice. You really want to use the the earlobes if the database is using the earlobes, and most do. Most QEEG databases do. But for training, there is a fairly similar signal between A1 and M1 if you're using like C4 as the active or CZ. But if you're getting close to it, you're starting to get different effects, you know? So I would say that it's not the same. And you can probably just paste on a flat wire onto the earlobe itself and put a little, tab of tape around it if you need to. All right, so my right ear is going into the second, the black socket. Hey, Sonia, good evening. Nice to see you. How are you doing tonight? Hope everyone's doing well. All the gangs here, people are rolling in, saying hello. Love it. All right, so now I have ear clips on, but no brain wires. So before I spilled water everywhere, let me clean that up. There we go. I also happen to have a little kitchen towel, so that was useful. All right, so now I need a scalp wire. I have a green one here. Let's pull that out. I was trying to get my cat from grabbing the wires, and instead I knocked over a bottle, so, instant karma. All right, so green wire. See, even when scattered and live streaming, you too can set up neurofeedback. So I've got a little flat wire here for the scalp. The joint of the wire feels a little bit floppy right now, which might mean that the wire is on its way out. So C4, you can see it's about halfway between my crown or the vertex and that right side. Yeah, it's about right. There we go. All right, now let me plug this in to the third location on the amp, the red socket. So if you're curious, if you're following along at home, the current wiring is set up this way, and I have the one channel, one signal on my head. So let me start up Eager and explain a little bit about the neurofeedback session, and then I will make sure my hands are not covered in paste and open my laptop and give you some of my thoughts on these cool new aging findings. All right, so let me run the session, and I'm going to pick a simple game tonight because that's all I have installed on this system. And we will do variable.mazes. I love v.mazes. It's pretty cool. So now we can see it says initializing there. Well, let me turn on the other video, the other screen. Display capture 2. There we go. All right, so I have, let me move myself over. So there's raw signals there above my head. That's raw EEG. You can tell it's real because now it's got noise because I moved. Or if I clench my jaw, it'll go super high amplitude for a second. Right now it's pretty clean, but clenching my jaw, that's muscle tension, or EMG. This is how you can tell that muscles will get in the way of the measuring the EEG. That's also why I have those little blue lines around the raw signal. It's clipping out any high amplitude blinks and movement and only letting through the actual EEG. Now, I have 3 other frequency ranges below that. So let me move myself over a tiny bit. Okay, so you got 4 to 7 there, just to the I guess left of me, and that's the amount of theta brainwaves that I'm making. So let me go and quickly scale the system a tiny bit. There we go, F11. Okay, let's F12. There's F11. Okay. So what we're looking at is raw signals there on the very top of the screen. And then this is theta. And you can see that I'm making 25 microvolts. Sorry, I'm making 21 microvolts there, 22 now. That's the AVG, the average. So moment to moment, you're seeing a changing height of that wave. That's the amount of theta that I'm making. And generally, theta is like turning off the tissue briefly. It like lifts its foot off the brakes when a part of the brain makes a lot of theta. And so it's often in the way a little bit of our cognitive process or our experience, or our self-control. So we generally train it down, not always, but for most protocols, you train it down. And so I'm moving so it's artificially inflated here. But as I sit still for a second, you'll see my average will drop. There it goes. So what I've done is set those lines outside, you know, down here, most of the way outside the waves. But every so often the waves get big and that bursts outside the lines. That stops the system from running. Let me scale this. Oh, that's wrong key. There we go. All right, now I change the threshold. So it's 38 microvolts. So as long as my brain stays below 38, it'll let the theta condition pass. I have a reward band here. I want to make more of this. So I've set the threshold for 10 microvolts. If I'm above 10 microvolts with this SMR beta, if I'm outside of the range that's being limited, in this case above 10.38, you can see I'm making 12. That lets the condition pass. And then we have another inhibit condition down here. So that's the basics of it. I'm going to hit start, which is F5 on Eager. You can see my little Pac-Man. Oh, where's my audio? Let's see what's happening with the audio. It looks like my audio is not currently set up. I think the audio on the computer is going in the wrong source. Let me change this to the USB speakers. There it is. Way too loud. All right. So what's happening is whenever my brain spends half a second in range or staying in range of all those 3 bands, the little Pac-Man's going to move and eat some dots. And a little beep will happen. And whenever my brain spends, half a second not moving in the right direction or moving in the wrong direction, that will both stop the Pac-Man and it will make the beeps pause as well. And in this game, one added wrinkle is the amount of theta, the amount of the slow brainwave band, is also tied to the size of the dots on the screen. So what that means is, turn the volume down a little bit. What that means is you can see on the screen, looking straight at it, if your theta brainwaves are surging. So if you're moving too much or you're getting super distracted or tired, you get a visual cue, which is kind of a fun thing. Now, we don't have much control over our brainwaves, and so it's not a voluntary training process. It's mostly involuntary. If you haven't seen this before, what we're doing is neurofeedback. So we're measuring the brain moment to moment, my brain, and watching some brain waves we want to make stronger and watching ones that we want to let relax, let go down in power. And whenever the brain briefly moves itself for half a second in the right direction, so to speak, on its own, that gets applauded by the computer. A little beep happens and the gameplay occurs. And the brain prefers that to the game stopping. So whenever the brain moves in the wrong direction and the game stops, the brain goes, oh, okay. And it figures out that the bursts of brain activity that are being measured that drive the game are the ones that it should make. Sonia's asking, when doing neurofeedback at home, how are we supposed to locate brain regions accurately? For example, I know T6 is behind the right ear, but how can I pinpoint it with high accuracy? Thanks. Yeah, that's a good question. Couple ways. You can learn the bone landmarks on the skull. We will teach you those. We also often give people the big landmarks with a couple of ropes that have knots tied in them, little cords. So you can lay and find the Z line and the C line very quickly. But there's a systematic way to find the locations. Everything's 10% or 20% away from everything else. In fact, the system's called the 10-20 system because of that. So once you find the big landmarks, you can then subdivide between regions to find other locations. The one you mentioned, T6, posterior temporal lobe, is a little hard to find. And so what you do is you find sites that would intersect with it or have lines that would mix. So you can find this little notch right here pretty easily. This is my auricular notch on the right. Up an inch is going to be T4. So that's the height of the T6 as well. There's a kind of a hat line that rings the head. So at this level, let's move my wire. At this level, you would go back, and at some point, that's going to be on T6. And in terms of how far back to go, well, you go as far back as your PZ. Sorry, I moved the wire from my head. You can see I have no signal quality now. Should recover. There it is. So the long answer is that you would learn the adjacent landmarks and you would find it. In this case, you could find T4 and O2 and split the difference, or you could find T4 and go back and P4 and go down. So I'm waiting for my noisy screen to clean up here. There we go. We also have been using some placement caps. Some of our clients are getting these mesh caps that are mostly open, and that you can find, as long as the cap's a good fit, you can find the locations very quickly that way. And then third or fourth, a lot of our clients will just take a quick photograph of their head and drop it in their private chat. We give every client a Slack channel that's open 7 days a week and staffed at least 12 hours a day. And that means that there's always someone there to help double check a placement or help you learn to find location on your head. So we try to make the execution piece of it a lot easier so you're not sort of struggling to figure that piece of it out. So you can see there red and blue lines, and what that is points and time. In this case, the time is red. That there's a lot of noise in that maze, so I didn't get through it very quickly. It stopped the Pac-Man quite a lot through all the talking and movement I was doing. So I got a lot more time in the same points, the same beeps, or the same dots I was eating. You can see, even though I'm moving and talking and distracted, my theta average is still going down. Now it's at 20. I bet I can make it go down voluntarily. Let me bring that screen up so it's bigger for me. There we go. I'm going to concentrate and make that 20.4 go down. So I say you can't control your brainwaves because you can't feel them. but the act of concentration does suppress theta. So you're seeing I'm dropping it now to 18, 17. See how low I can get it voluntarily by concentrating. It's pushing back. You can see it in the signal. The raw signal is having these little theta bursts as I push on it. It's trying to come back. Below 17, let's see. Yep. So there's me dropping my theta by what? 25% just by concentrating across 30 seconds. All right, now I'm going to relax. And it's instantly going to climb back up, right? Yeah. So this is me showing off. Stupid human trick. And now it's 17. Now it's climbing. Now I'm more distracted, not thinking about it. But when I was really stabilizing my attention, you see, you can get some sense of how your brain's working, even if you aren't really controlling it per se. You're seeing what the brain's doing reflected back on the screen. And that's really what's happening in neurofeedback. So happy to answer more questions, but let me pull up some of my aging topics. Keep an eye on the questions while I'm training. Got to change over in a few minutes. All right. So a bunch of stuff happened in the past couple of weeks, like really urgent things. A lot of things that potentially are really meaningful for different folks with complaints and challenges, different aging conditions, different pain conditions. So I wanted to run through about 10 items and just briefly touch on what it is and what it might mean. Well, what the finding actually seems to be implying. So first, there's a technique called TDCS, transcranial direct current stimulation, where you send low current stimulation pulses through the head, through the brain. And it's been one of these more fringy areas of biohacking for years, and it is used by biohackers, by psychologists, and a lot of people swear by it, but it's not one of the better understood biohacks. And the idea of zapping your brain with electricity, as you may understand, isn't everyone's first place to begin with biohacking, nor should it be. And so a study in April, recently this year, found that just 20 minutes of TDCS, 20 minutes of technique for 5 days in a row produced pain relief benefits that lasted 3 months. And that was compared to a sham stimulation. So there was a durable effect on chronic pain, on acute pain and chronic pain for 3 months after 1 week of stimulation. Now, in this case, I think stimulation might be the wrong word. I have to look more deeply at the paper, but my guess is they're doing cathode and cathode, of course, with TDCS. You have a plus and a minus. And where you place those matters in TDCS. So I always get this wrong, but I think where you place the cathode is what becomes less activated, less likely to fire. And where you place the anode is more likely to fire. So they must have been placed in the cathode, in some of the chronic pain areas, the front right, et cetera, that we know are somewhat involved with the experience of pain. So that's a good paper I could dig more deeply into, or pain in general if you want to know. So next we have the University of Texas at San Antonio. So UTSA has a neurofeedback program being used by therapists, helping to make significant impact on anxiety and PTSD, being used there at the university. So it's doing actual neurofeedback, a great in the field, been around for years and years. Mark Jones is involved, and he's really helping people come to the perspective that trauma changes the brain, and taking a physiological perspective on that can really inform not just the physiology, not just mechanics, but it also helps the therapeutic picture in general, and the delivery of psychotherapy for anxiety and trauma can be really accelerated by adding neurofeedback. So those are my first two about the brain. I want to shift down a little bit and narrow down into more cellular level phenomena. So first, there's a new finding that came out in Nature recently, and it's a study that at first blush, the experiment they did, you kind of like, yeah, all right, fine. But the results they got are so exciting. So here's what it was. Essentially, it was a blood pressure evaluation study, figuring out, what is the risk of having high blood pressure, and is it potentially related to aging in a significant way. Now, we know that blood pressure goes up with age generally, but it's sort of like a correlative effect in some theories, just kind of goes up because the system's less efficient, or maybe even compensatory in some other theories where it's trying to do something to help offset some metabolic need that's still there, but the delivery mechanisms might be reduced. So there's been different theories about what it is, and we also have different theories about what healthy blood pressure is. So the study was done looking at blood pressure at 140 or 120 or below for the top number. And historically in the 70s and 80s, 90s, we were told 140 over 90 was okay. And now we know that that's probably a little high. And part of this researcher's question was, is that actually meaningful? And is it a function of aging or is it potentially a cause? So he took two groups and had them do targeted interventions, essentially trying to lower their blood pressure, and watched two groups. I think one group was mostly a wait-listed sham. So they were being measured and there was intervention and attention, but there wasn't an active intervention that was the same. In the other group, they were doing active interventions involving exercise and a few other things to bring their blood pressure down to a target of just 120, just 20 points in the systolic. And, 120 is considered healthy, and 140 is sort of considered healthy, and even 130 might be fine. Let me change my protocol over. We're doing a PZ for the second half. And so the research was supposed to run for 6 years, and they stopped it after about 3 years because it appeared like they had a very significant trajectory modifying intervention. By the 3-year mark, the progression of dementia in those populations was showing a 15% difference. Really, aging and dementia phenomena are on this sort of like trajectory for many aging phenomena. And we have symptom modifying, but not disease trajectory modifying treatments. And they found after 3 years, they're actually modifying the disease trajectory significantly. And so they projected that with these interventions, lowering your blood pressure below 120 reduces your cause, your all cause, not regardless of, Alzheimer's, dementia, Parkinson's, all cause dementia reduced by 15%. It's a really, really large effect in the aging literature. So if your blood pressure is a little high, that's a useful one. Let me stop and answer some questions while I set my next session off. How's my wave quality looking? Signals are pretty good. Let me go change the session. Control, no, it's function F5. There it goes. Now it says PZ. And then once more to make it start. There it is. We'll answer some questions. Hi, Lisa. This is Madeline's mother. Do you see a difference in effectiveness of neurofeedback between adolescent girls versus boys given brain development? I don't really, no. I would say that some of the complaints vary a little bit. I'm not sure that's the brain or the sociology, the socialized, constructivist versus constructionism kind of conflict that girls are exposed to a bit more. Identity versus what you're being told about identity is more aggressive, I think, for young women, especially in physical appearance, than it is for young men. I think that has a little impact on the types of things we see a little bit. But no, I think neurofeedback is as impactful for young men and young women. It seems to be a little more impactful for very young people. And then it's pretty impactful all the way until I would say you hit your mid-70s where the impacts can slow down a little bit. I did a live stream a few weeks ago on this S-shaped curve we know exists now in aging, a discontinuous drop-off across different points of life. And based on that, we would assume that up until about age 59, there should be really similar effects. And then after that, up until about age 75, there should be some reduction of effect, but not a huge impact. But I don't think gender or sex really has a huge impact on if the brain is changeable, because it's always changeable to some extent. And we might get young women and young men, adolescents, at different stages of development at the same age. But, you know, if you give me two 13-year-olds, well, you give me 10 13-year-olds that are boys, and some of them are already, you know, quite advanced and have secondary sex characteristics and are post-pubertal, and some aren't. And, you know, girls at 13, many more of them will be, you know, in a different developmental stage. But people are so variable that I don't really think that the phase of development you're in at that level matters that much for impact of neurofeedback. It seems to work really well regardless. So thanks for the question. Appreciate it. Let me see more questions. Sonia's asking, can a kid's brain not be receptive to neurofeedback at all? Let's say after doing 20 sessions of neurofeedback, each less than 10 minutes, the intended goal is not fulfilled at all. What would we deduce? We would deduce that the wrong neurofeedback was done, probably. No, neurofeedback is not a special process that's like really magical and only works for some people. It's tapping into a basic associative learning that all brains are doing. So if you don't get the effects you're looking for, it means the wrong exercise was applied. You know, you go to the gym for a torn shoulder and do calf raises, not so much benefit on your shoulder. Maybe you might hurt it, in fact. So you have to kind of tailor the process to the person. And also I find that a lot of the, at least in classic or traditional neurofeedback, the right way to do it involves being very iterative, adjusting as you go, seeing how it feels, learning from the after effects you get from each protocol, and then moving ahead like a personal trainer, a lot more than like a doctor or therapist. So no, as far as I know, it works for all brains. And learning, associative learning and neurofeedback, it just kind of works. I mean, Sonia, it's no real different than if you're a little kid flopping around and you do a little baby push-up and you can be like, oh my God, I can see 20 feet. Wow, or 12. The brain remembers the unique conformation of neurons that were needed to get that information, and it reaches for the information again a few hours later, and the baby does the baby push-up. So no, it's not really a voluntary process, the learning that's going on, nor is it effortful. But because of that, it's very, very similar, whether or not you're a, you know, curmudgeonly old scientist like me, or a little kid, or an animal. You know, this was discovered on cats. Cats are notoriously bad instruction followers. It works really well on people that are nonverbal, people in comas. It works plenty fine on disgruntled CEOs or annoyed teenagers who don't want to be in my office. So it's really getting the brain to train itself and then noticing the effects you've gotten, then they wear off. And if you like the effects, you double down on them, reinforce them, and gradually build them up over a few months until the brain takes over the practice, and then they're stable. Lisa's asking, and what is the youngest age I would recommend for children? So Lisa, there's an answer that is sort of the field of neurofeedback, and there's an answer of what actually works and what you might need to do or want to do. In general, the field, we would say 4 years old, because at that age, people are generally verbal enough and have enough control over their behavior, and often have some language to report. You can often understand more about what's going on. So a lot of providers that work with latency age or little kids will say 4 years old. But I can't tell you the number of parents I've had bring their kids in at 2 years old and say, oh my God, or 2.5. Oh my gosh, we just got our first autism diagnosis. What are we going to do? And I have a lot of experience with autistic spectrum. And, there's a lot you can do, but there's no real reason to wait for things like neurofeedback. And so from my perspective, it's not worth doing neurofeedback if it's not going to add something, or if it's really onerous or burdensome. You get a 18-month-old or a 2-year-old who's tons of sensory issues and is screaming the whole time. Don't do neurofeedback. But I'm working with a kid right now who's 2.5, who's having really large changes with eye contact and language and all kinds of development, really accelerating through, I think, the neurofeedback. And from my perspective as a physiologist, I really am limited by our ability to understand what the goals are for one person. And we often can. Kids got seizures or OCD and choose their lip or something, or stimming, or bedwetting, or not sleeping. Those are obvious things, and you can get the brain to change and see those things. But another piece of it is that I have a QEEG, or brain mapping, as a piece of our tool set. And I really do rely on understanding, or at least modeling some perspective on the brain, to know what to do and then how to proceed as the person notices something or the people around them notice things. And so for me, a lot of the limit is, well, can I get a QEEG? And I have little tiny baby QEEG caps that are these little tiny ones. And the databases that we use for comparisons, the population metrics, those go down to 6 months of age. So the question is, why does your little kid need neurofeedback? You know, if it was my 2-year-old, I'd probably grab a brain map just because, like, hey, let's look at the 2-year-old. The same way you might measure their shin bone and project their height, or do their genes if you care about that kind of thing. So it's interesting. But I probably wouldn't put subject an 18-month-old to a cap on the head and cold gel unless we were concerned about seizures or autism or something like that. And then, hey, let's get in there. Let's help understand, develop perspective, develop agency, and you can make change. So I do work with an awful lot of very young kids over the years. Yeah. Radar Ashwood's asking, wouldn't I say that there are some people who don't tolerate any neurofeedback, though? I don't think so, no. I think there's some people for whom certain protocols are very, very activating or fatiguing. I think there's some techniques in neurofeedback that are more likely to produce abreactions. I don't think that a brain in general won't tolerate neurofeedback. I think there are some rare cases where things are super acute, and you might not want to train until it's post-acute. That might include with active brain injuries, like a new bleed, a new major TBI. Might want to wait a few days or a week or two, but not from like a concussion or something. Jump right in. Or if somebody has a really, really active and high-level Lyme or mold exposure with co-infections and the whole system is hair trigger, you should probably deal with that first and get some stability, because the neurofeedback is mildly taxing, and people that have deep fatigue for everything that goes on will feel it from neurofeedback as well. But I don't think categorically that there's any category of person, type of person or complaint or goal that wouldn't respond to neurofeedback if you did the right neurofeedback. Radar is also opining, some people have done neurofeedback on infants. Yeah, I mean, I have. I've done 6 months old, once or twice for 9-month-olds. Now, generally, that's a seizure disorder. Someone's having seizures, and not just febrile seizures that kids often have, but ongoing seizures. And at that point, we're doing a little baby EEG. We're recording long enough to see what's going on and try to identify the focus of the seizure. And then we're training SMR. And it doesn't really matter if they're 6 months old or 9 months old at that point. We're going to try to help and generally really make some impact, because again, this is mostly involuntary. It doesn't really matter if you're a 9-month-old or an 18-month-old or a 25-year-old. It's mostly involuntary. All right, let me ask go over some more of my 10 aging hacks for the day, or for the podcast or the live stream. Great questions, guys. Thanks for that. Let's see. All right, so I mentioned the blood pressure change. This might be a reason for you to consider keeping your blood pressure under 120/70, because the all-cause death or all-cause for dementia reduction is so striking, especially in the literature. There's very little that jumps out at this level. We also had another finding in March. Researchers found a protein called AP2A1 that seems to be involved with cellular aging. And it's a protein that when suppressed in cell lines, it reverses cellular senescence and promoted cellular rejuvenation. So this is a protein that interacts with integrin. It seems to be involved with the way that integrin or the cellular matrix starts to degrade, i.e. collagen. So we've always thought, again, that collagen degradation was a feature of aging, not a cause. But it looks like if you reverse the collagen or cell matrix aging, you reverse aging in the cell, and the cell itself rejuvenates. So this is a really interesting finding, again, suggesting at an ancillary mechanism that may be more causal, just like blood pressure. All right, from our Canadian friends, University of Ottawa research has demonstrated in April that cold exposure, like cold plunge, may offer significant anti-aging benefits. And the research studies go back and forth on this one, but they found that 10, these are healthy young men, doing daily cold water immersions at 14 C or 57 Fahrenheit for 1 hour, that's cold, over 7 consecutive days. So they measured an initial period of reduced metabolic autophagy and cleanup and anti-inflammatory stuff. There's a day or two of reduced like cellular repair. But after that, there was an increased rate, and this team was recovering faster. So the idea was to show that you can use cold exposure like this in a team, an intense team of young men, to show faster recovery from the workouts. Now, one caveat on that, if you're a bodybuilder or somebody going after the hypertrophy, the large size and the muscle density, you don't, and maybe even someone who's doing strength work, you don't really want to do a cold plunge or let me start my session here. You don't want to do a cold plunge or cold shower or ice bath after a strength training workout if you're trying to become big and strong, because you actually do get a fairly significant reduction of muscle protein synthesis and volume and strength if you do a cold plunge after hitting the weight room. So it's good to do that kind of thing on different days. And we saw that in this study, they were doing it across 7 days in a row. So these were healthy, athletic men, and I'm not sure if they measured muscle protein synthesis, but you would assume that once you've hit a certain level of fitness, you could use techniques like this to manage significant stressors like major times of play or doing more extreme things. I have a couple friends, a couple clients that are ultra marathoners and that do multiple days in a row of these extreme sports. And in those kind of environments, you could probably use this technique to recover much, much faster if you were all adapted to it. Let's see. Lisa says that's exciting, positive. It is, right? I know. We're learning more and more about aging all the time. Radar Ashwood is asking, are people with epileptic seizures generally overstimulated? I mean, at the time of a seizure sometimes, but not really overstimulated. A seizure is a coherent event in a slow brain wave. It's an ictal event, a spike. So it's really a delta that's too high amplitude, too sharp, and is recruiting neighboring tissue to make that same wave in phase. And then when it's a tonic-clonic or grand mal, you get this resonant effect where it bounces back and forth between the hemispheres and grows as it bounces. This is why split brain subjects would have relief from this kind of seizure. But no, in the case of other seizures, complex partial, absence or petit mal, no, I don't think overstimulation is a good characterization, although there's something going on there. Sonia's asking, is neurofeedback efficacious for inhibiting or even eliminating epileptiform discharge? It sure is. Yeah, we have neurofeedback because we discovered it reduces seizures by mistake. It's one of those serendipitous findings. So Dr. Barry Sturman in the mid-60s was examining how risky methyl hydrazine or rocket fuel was on cats that were being exposed to rocket fuel vapors in an airtight plexiglass cage. He was doing this for NASA to figure out how dangerous the rocket fuel vapors were for our scientists or our astronauts that were breathing them in. And so Sturman had a bunch of cats, about 32 of them, I think, in the study, and he exposed them to rocket fuel. And he kept a time of how long it took for them to develop symptoms, including drooling and crying and having seizures, and then coma and death. And what he found was that 3/4 of the cats, 24 of the cats or so, had seizures happening, early instability events, and seizures happening by 40 minutes, all of them. And the other 8 cats weren't doing that. Their seizure, they weren't showing the same like stumbling, ataxia, drooling kind of things nearly as early. And they were showing seizure activity more like 2.5 or 3 hours in, if they were showing it. So Dr. Sturman was like, whoa, have I discovered seizure-resistant breed of cat? That's interesting. But no, he had done another experiment with a bunch of cats 6 months prior, where he put a little eyedropper taped inside their cheek, and whenever they made a certain brainwave, the cats make a lot of sensory motor rhythm, a deeply relaxed body, laser-like focus. Whenever that surging brainwave showed up that cats make, he squirted chicken broth into their mouth and rewarded it, and did a little bit of reinforcement learning, and found that you can reinforce the signal's amplitude up over time. So you can create more SMR, more low beta brain waves in cats through reinforcement learning, which was interesting. He was a learning scientist primarily. And so that was cool. He put all these cats back in the subject pool from this basic experiment. And when he pulled out cats later for a different experiment, some of the cats from that first experiment ended up in the second one. And those were the ones that were seizure resistant. And to continue the story, he had a lab manager or a lab affiliate who was medication resistant, having tens of seizures every month. She was on Tegretol and Mebarol and Dilantin and all these heavy-duty neuroleptics and still having seizures every month. So they built her a machine to do audio feedback on SMR. And she trained her brain off and on for a year. And the last half of that year, she went off all of her meds and she remained seizure-free for over a year. And that was the start of the field, basically. At the same time that Dr. Barry Sturman was discovering that at UCLA, Dr. Joe Camilla was discovering it in Northern California. And he was doing work on voluntary control over alpha waves, the hippies in the Bay Area. And that was something that actually, I think, while it's interesting, wasn't as powerful in terms of setting up our field the same way that SMR training has. And so, yeah, I've worked with hundreds of people that have some form of seizure disorders, and they usually have really good change. Dr. Sturman did a lot of this publication research, and a lot of it got pushed back from the epilepsy journals and scientists and maybe drug companies. But he published a review article in 2012 or 14 looking at, to that point, the state of the literature for the previous 50 years on what neurofeedback was doing for seizure. And he found that across papers, the average degree of control over seizure was 50%. It was 50%. And 5% of people were getting complete control over seizures for at least 1 year, which is when the studies were following them until. So really powerful effects. And I've never seen somebody get an effect like 50%. It's always much, much more control over the seizure. So yeah, really powerful for reducing seizures in humans as well as cats. Radar is asking, I wonder if the first NFB patient is still alive. I wonder if she is. Dr. Sturman died not too long ago, about 2 years ago he died. 90, in his early 90s, I think, as an emeritus faculty still. Very nice guy. I've talked to him a lot over the years. Very kind. All right, continuing our whirlwind tour. UT Health San Antonio researchers published in March another finding showing a drug that seems to selectively remove senescent cells or zombie cells from the liver. It degrades two proteins that build up, BCL-XL and BCL2. And this drug reduced fat buildup in the liver, fatty liver, decreased scar tissue formation, and inhibited liver cancer development with fewer toxic side effects than other senolytics or anti-senescent compounds. So there's something here with cancer and with the anti-aging, the anti-senescence stuff as well. All right, let's shift over a little bit to nutritional and metabolic interventions. In Colorado, University of Colorado, researchers in April published a paper showing that the 4-3 intermittent fasting model produced superior weight loss compared to traditional calorie restriction. So the 4-3 model is dieters eating freely, eating regularly 4 days of the week, and then 3 days of intense caloric restriction. So it's sort of a cyclic keto or a cyclic fasting thing. I've done things like this, really, really powerful for shredding off huge amounts of body fat. And in this case, they found that the group that did that version had a 7.6% weight loss, and the traditional caloric restriction group had a 5% in a year-long study. So pretty good length of that. Another study in March looked at ketone ester supplementation, found that working memory increased after ketone ester ingestion. So that's pretty cool, regardless of metabolic syndrome status, which of course reflects earlier research from 20 years ago showing that in insulin resistance in the brain, type 3 diabetes, early dementia type phenomena, the ketone pathways are spared. This is why you can get some recovery of brain function if you go into a keto mode or a paleo or primal mode before too much is gone. And so this March study found that the metabolic syndrome status did not actually impact how well the ketones improve working memory, which is pretty cool. However, blood glucose levels also decreased following ketone consumption, and the appetite suppression impact of the ketones were only seen in those people who were metabolically healthy. Those that had metabolic syndrome, insulin resistance, did not have an appetite suppression effect. So interesting. January, or going back a little further this year, there's a compound called rapamycin that was, the name comes from Rapa Nui, the Easter Island, because it was first identified in the soil there. And it's this compound that has all these interesting immune and autoimmune and anti-aging kind of phenomena associated with it. And it's moving out into more use. The January study showed that essentially the commercial prepared versions are much, much different than the versions that are hitting the shelves everywhere being used by formularies. Pharmacies creating their own versions are not very good, apparently. So blood rapamycin level also seemed to peak 2 days after you dose. So this is underscoring the idea that there's this long response curve and different levels of dosing coming at you. So we may need to be monitoring. If you're somebody who needs rapamycin because of cancer or some other anti-aging phenomena, autoimmune phenomena, you may want to have your levels monitored routinely to make sure they're not building up the same way you would with something like lithium, which works really well, and unless it builds up, and then it's really toxic. All right, so we have a genetic or two. Let's see. The last one here. This is our final one. There was a study in February demonstrating that, this is a mouthful here, systematically delivered adeno-associated viruses encoding an inductible OSK system extended the median remaining lifespan of elderly mice by an astonishing 109% compared to controls. All right, so what's happening here is they're looking at Yamanaka factors, these factors that show up in in cells as we start to age. And there was a compound, one of the Yamanaka factors is OSK. It seems to be related in some of the signaling. So they created a gene therapy in mice which targets OSK. And they wanted to look at what that would do to the Yamanaka factors, what that might do to the elderly mice's aging. And so I forget the exact, weeks of mice age. Mice don't live that long. But they basically showed that giving it to elderly mice increased the remaining lifespan by 109%. So this, we don't yet know if this kind of thing would work in humans. Only about 10% of mice studies actually translate perfectly to humans. The rest imperfectly or not at all. But, a 109% increase in residual life would be like getting this compound in your mid-60s. When you might have, let's say, under healthy lifespan conditions, 20 to 30 years left, and it doubling that. Now you're 120, 125. And it's going to be healthy lifespan because of the way these compounds work, this sort of anti-senescent effect. So that means you're going to get at 60 suddenly, probably, I don't know what the mice looked like, but I've seen some of these mice studies looking at knockout genes for senescence, and you get mice that are old and gray, and their hair grows back in, they go brown. So, we're probably getting to the place maybe where you can get an injection at 60 and it can roll the clock back 20 years to 40 until the early parts of when the senescence started, probably. That's my take on this. Anyways, kind of interesting to look at these Yamanaka factors and how we might be able to get into genetic therapies to start manipulating them. Very, very interesting. All right, some more questions, more comments. Lisa is saying she seems she thinks that everyone should get a brain map as part of the overall wellness check. I think so too. It's not invasive and can support a healthy alternative approach to address proactively any issues. Not just that, but it provides agency without diagnosis. Brain mapping is not diagnostically precise. So it's not like looking at a gene and going, oh my God, I have a disease. It's more like looking at a piece of physiology and going, oh, it's working like that. I bet I want to change that. Kind of like looking at your lipid panel and going, oh crap, triglycerides. I better back off in the Ben and Jerry's. You kind of learn this agency, what is measured is managed, a la Drucker. And so if you learn to manage or measure your alpha peak frequency, your amount of delta, your beta power, and you learn how to correlate it with what you're feeling, with how your brain works. It gives you control over which interventions you choose and how you pursue brain changes, and lets you really move forward knowing how your brain works. People are always shocked when I go over, not always, but like 90% of people, when I go over brain maps with them, say something to the effect of like, oh my God, I had no idea. You can see that? I had no idea, because we aren't taught about our brains the same way we might be taught about our waistlines, So it's important to understand your brain, and the brain's more changeable than the body too. So yeah, you can do a lot to measure and manage these resources. Lisa's asking, regarding diets, which one would I recommend is both healthy for your body and brain based on all the ones I have done? I would say we're probably in like the Mediterranean-ish diet, or the primal-ish or paleo-ish diet, essentially. So some general rules of thumb. I would say these diets that are super healthy are high protein, moderate fat, and low carb, with free sugars and easily digestible carbs. They lean into above ground vegetables and colorful vegetables and fruits. They generally avoid starches, definitely avoid refined starches and lots of excess oils and things, and lots of sugars, obviously. And beyond that, humans are pretty darn adaptable. So you can actually be really healthy if you are careful with all kinds of different human diets. But I think that the best anti-aging one is probably that sort of like Mediterranean/paleo/primal version, which is, again, moderate to high protein, lower fat, even lower carbs. So it's not keto. It's not like 90% fat. It's more like you want to have half as much fat as you have protein. So have enough protein for satiety, muscle building, muscle protein synthesis, etc. And if you need a number, you want to aim for something like a gram per kilo, essentially, of body weight. Unless you're doing calculations on lean mass and things. And women a bit below that, men a bit above that. But a gram per kilo is actually kind of fine. And you can go above that if you want to. If you're doing hardcore things, if you're having a lot of illness, you may want to go above that for protein. But, that much protein, and then half that in grams for fat, and half again for carbs. And any additional energy you make or need because you're not having enough calories, then you would increase the fats and the carbs appropriately to make up any energy needs. You might have carbs after exercising to make sure that they are not requiring a huge insulin release to absorb, for instance. So I also think that we can sometimes find that individual metabolic things are really important, some genetic things, some methylation status, and that can affect what we, how we progress with what we eat. So you might want to do things like the Apollo Health Recode program, or at the very least do some basic testing around APOE to figure out the variants you have and how important it is maybe to avoid sugars and other things like that. So this is a very complex topic, because of course humans are really different. And there's lots of reasons we eat, not just for health and for pleasure. We eat for culture and ritual and all kinds of interesting reasons. And so I think we have to sort of live in a harm reduction world when it comes to food. We're not going to abstain from food completely, but we also have to realize food has hedonic tone. It has more reasons than just nutrition for eating. And so balancing our relationship with it becomes very important. And so I would say that just like exercise, the diet you do, the eating plan, the style of eating you do that you can adhere to because it's basic and easy and reinforcing and feels good is the one you should do. And humans can react well to any more extreme diet in the short term. But I think the one that's sustainable are the more, good protein, moderate fat, low carb, and lots of leafy greens and above ground veggies and fruits. So there's my brain healthy diet. All right, guys. Well, thanks for hanging out with me tonight, doing some brain training and asking lots of questions. You've been a great audience. I really appreciate it. If you haven't yet, do me a favor, like the channel or subscribe to the channel, like the video, like another video. If you want to share these videos out across the interwebs, YouTube algorithm loves that. And so please let me know if you have any interest there, and just grab a thing and share it. Sonia's asking, to what extent can epileptiform discharges interfere with speech, working memory, and attention? To a great deal. even without having seizures, there's some evidence that many of the things we deal with psychologically have low-key seizures happening or low-key discharges, ictal events. And that's true of anxiety, depression, sensory issues, attention difficulties, sleep issues, mood issues. So yeah, it's actually quite common. There's some, across diagnosed neurological complaints, there's some evidence or there's some estimation that up to 1/3 of people have undiagnosed seizure activity going on in populations like for neurodevelopmental change, like autism, for instance, and those are the numbers. And so it might be a lot more than we realize. But also remember that all brains are kind of on the edge of having seizures all the time, and we resist them successfully. You know, life is the balance between order and chaos. It's the edge of criticality. And falling over into chaos is a seizure, but falling over into order is just death. So you kind of balance between those two states to be alive, and resisting devolving into chaos or order is what the brain tries to do. The same way that walking is sort of resisting falling down while you're about to. That's what life is. It's resisting the devolving into chaos, and organizing, dampening, shaping the activity instead. So human brains are really good at always dampening that system. And all humans have a seizure threshold that we're kind of constantly getting good at adjusting to keep that system stable, but also keep it flexible enough so the brain can become plastic and change. You know, the places the brain develops seizures are the places the brain, well, you can develop seizures from injuries and things in certain regions, but the place the brain might develop seizures without an injury is often the hippocampus, because those are the places in the brain where you have the highest plasticity. So the places that are very, very, very strong plasticity, very strong changeable areas, will sometimes change and become too organized and then develop these chaotic high amplitude waves that will bounce back and forth. So plasticity is good until it's not at a high level. All right, guys, there is your talk for the day. Have a great evening if you're watching live. If you're watching tomorrow, I know we have a whole group of people that watch the next morning. Hey, guys, from the past. Hope you're doing well. Please feel free to leave comments and questions. I do come back and answer them. And I will talk to you guys in a week or so. And until then, take care of those brains. And thank you, Sonia. I really appreciate that last bit of kudos. You are also gold for showing up. All right, guys, take care. Bye-bye.